Let's quickly learn about serverless technologies. If you look at the history of serverless technologies, it all started with physical servers in the data center. So if you look at the back in the days, when you want to run a software, you need to get a hardware to run it, put it in a data center, plug it into the network, and then install all your operating systems on top of it, and then run the application. People found that it's difficult to manage, especially when you want to move the application from one physical server to another physical server, let's say due to a hardware failure. It's a very cumbersome task. So the people move into the virtual servers. So that gave you flexibility around how we are going to move these virtual machines, how we are going to upgrade them from one physical hardware to another physical hardware. But you still manage the underlying hardware. Then came the cloud providers. What happened during that time was you moved your virtual servers into the cloud, and that gave you a better server utilization because now you are not stuck into some hardware that you purchased on premises. But it still had some issues. Virtual machines are heavy to run. And then gradually a new technology emerged like containerization, which allowed you to increase the server utilization and also to better manage the application dependencies. Over time, people realized that these virtual machines are still not heavily utilized. If you have an application that is not using the CPU and memory, you are still paying for that. So what happened over time is people realize it's better to pay only for the time the application is actually using some compute memory or storage resources. And that's where the serverless technologies like Lambda came into picture. In summary, what it means is that you don't have the overheads of managing the servers. You don't need to worry about patching your operating system, making sure that there's no any security vulnerabilities in the operating system. So all these overheads that you used to have in traditional virtual machine-based environments goes away. You get decent flexibility in terms of scaling, which means that regardless whether you have 10 users or million users, the application is smart enough to scale automatically in and out. And that automation helps you to cater to different geographies very quickly, different marketing campaigns that you are running, because you don't pre-provision or pre-purchase any hardware or virtual machine well in advance. The technology itself is highly available by design. So if you are using serverless storage technology like Amazon DynamoDB, it is by design deployed into a highly available multiple availability zones. Same for AWS Lambda. So if you are running AWS Lambda, it's by design runs on multiple availability zones. More importantly, you don't pay for any idle capacity. So when you are using a virtual machine, even if your application is not actively running, you still pay for that virtual machine. But in the case of serverless technologies like AWS Lambda, unless you are running your code, you don't pay for that. You only pay for memory and compute usage of AWS Lambda. Behind the scene, usually all these serverless technologies use some sort of an event-driven architecture to give you a design differences around event-driven architecture and the traditional monolithic kind of applications. Traditional applications use this directed method of communicating. Like for example, you may have application 1 that communicates with, let's say, some kind of a web service and then waits for that web service to return some values. Whereas in the event-driven architecture, you follow this fire and forget kind of approach. When your application state changes, it fires an event, and whoever interested in that event can subscribe to that event and then act on that change of state. There can be multiple events that happen in your application. So some of these events can be triggered when you upload a file into Amazon S3. Another event can get triggered when a message arrives into Amazon Simple Queuing services. It can even be an invocation of a REST endpoint in your API gateway. So regardless of how these events happen and also how you have linked them with AWS Lambda, Lambda functions will trigger for these events. And because it has the scalability to automatically scale in and out, even if you get 10 events, maybe 10 Lambda functions runs. But if you get, let's say, 1,000 concurrent events, then all of a sudden 1,000 Lambda functions can quickly function and then execute. The good thing here is that you only pay for your usage, how much memory and CPU these Lambda function uses, and you never pay for your idle capacity. Here's an example of an event-driven design. The beauty here is, let's check the checkout process. So if you have a lot of customers all of a sudden checking out from your e-commerce website, that piece of the application can scale out very easily depending on your demand on your checkout process. And also if you have some kind of, let's say, a long running process like completion of an order when you ship an item, you can output some values into Amazon Simple Queuing services, and some other systems may pick or listen to this simple queue and then pick the messages that it can process and then upload the status accordingly. When we are talking about serverless, it's more than just compute. You may think serverless is just about AWS Lambda, but there are so many other underpinning technologies that include different data stores like Amazon S3 and Amazon DynamoDB, which is our NoSQL database. So Lambda functions, for example, usually runs for a very short period of time. So it may need to preserve the state, it may need to interact with some data, which it can use any of these data storage. Usually in modern application, we tend to choose purposely built databases rather than sticking into one relational database. So if you want to have lower latency access to some kind of a key value store, you will very likely use our NoSQL technologies like Amazon DynamoDB. Whereas if you want to use relational databases, you will use something like Amazon Aurora database. For some kind of object storage to store images, you will use something like Amazon S3. Serverless technologies AWS offers also include some integration technologies. So that include Amazon API Gateway. For example, if you want to act on some sort of an API invocation, you will link Amazon API Gateway with AWS Lambda. So whenever your customers make some kind of a REST API invocation, Lambda will trigger, do some action, and return the result back to the customer. Same for Amazon Simple Queuing services, so Amazon SQS. This is used especially when you have some events that get triggered very frequently and the backend system cannot act on them. You will very likely buffer those events as messages on Amazon SQS and then later act on them using some kind of a compute technology like AWS Fargate or AWS Lambda.